All right. There were two main cases where we really had to find what the domain is because it wasn't negative infinity to positive infinity or all real numbers. And that is when we have a fraction, a rational equation, or a radical. So with rational expressions, what can't we have? What can we not have? We're allowed to have negative numbers for rationals. For a square root, we can't have negative numbers under the radical. But what about this one? The chat is open. What can't you have with fractions? So with fractions, we can't divide by 0, so the denominator cannot be 0. So since the denominator can't equal 0, we need to find what x values make it equal to 0. And to do that, we have to set the denominator equal to 0. So what x values make this equal to 0? Then why so quiet? Okay. What if we change it to to 2x? Is that better? All right, so now what? Mhm. So when x is equal to 6 and when x is equal to -8, the denominator is 0. So what does that say about our domain? When x is equal to 6 and x equal to -8, the denominator is 0. My English is all broken. Don't mind me. Since the denominator is 0 at x equal to 6 and x equal to -8, our domain is what? Yeah. So since the denominator is 0 at 6 and -8, that means our domain is everything except for 6 and 8, -8. When finding domain, it's easier to see where the function doesn't exist as opposed to finding where it does exist. So especially for rational equations, we find where it doesn't exist by setting the denominator equal to 0, because we know fractions can't have 0 in the denominator. So we found two x values that make the denominator 0. That means all other x values except for these two are going to work. That's why it goes from -infinity to -8, and then from -8 to 6, and then 6 to infinity. Make sense? All right. So what about square roots? You kept telling me what we couldn't have for that. What would you say again? We just can't have a negative. Yeah. Brian, what are you punching over there? So since the radicand, the whatever's under the radical, has to be greater than or equal to 0 to find the domain, that's exactly what we do. We set it greater than or equal to 0. So if we said 2x squared plus 7x plus 6 greater than or equal to 0, how do we solve inequalities like this? We're trying to solve for x. Yeah. So remember, whenever we're factoring and this value over here is not 1, we have to multiply it to c, which is 6. So AC and then we find factors of AC that combine to give us B. So after we multiply A times C to get 12, we find factors of 12 that combine to give us 7. 3 plus 4 is 7, and 3 times 4 is 12, so that works out. So we take 3 and 4 and replace it for 7. And who remembers where to go from here? Yes. Do you remember what that was called? Factoring by grouping. So after we group the first 2 terms and the last 2 terms, what do we look for? We look for the GCF in each group. So what's the GCF in the first group? Yeah. The only thing they have in common in the first group is x, and if you take x out, you're left with 2x plus 3. What about in the second group? Now we have 2 terms. What do these 2 terms have in common? And if we take out a 2x plus 3, we're left with x plus 2. Now what do we do? So this time it's not just equal. For inequalities, you have to flip the sign on one of them. So as opposed to this one we had to find where it didn't exist. But for this one, we were finding where it does exist. So we don't have to change anything when we write the domain. Any questions on that? All right, given the functions f of x equal to 2x squared minus 3 and g of x equal to 4x, we want to find the composition f of g of x. So what is number 1? Do you remember how to do this? Plug what in? That don't mean nothing. So remember when we first started and I asked you to find like f of x minus h or f of x plus h and all that stuff? Remember, whatever goes into parentheses takes the place of the x in the function. So if we're trying to find f of g of x, we're taking the function f and we're putting g inside of it wherever we see an x. So we start by writing what f is, leave a space wherever we had an x, and then we take g and plug it inside there. Does that make sense? So we're taking f and we're plugging g inside. We start by writing what f is. F is 2x squared minus 3. But instead of writing x's, we have to write g of x. So we have 2 times g of x squared minus 3. G of x, we were told, is 4x. So we substitute that in here. And when we simplify, we get 32x squared minus 3. Any questions for real? So when you square 4x, 4 squared is 16 and x squared is x squared. Better? So when you square something that's being multiplied, you just square each one separately. Hey Ryan, can you mute your mic? Thank you. You good? Daquan? All right, Lauren, does that help? Any other questions? If you don't say anything, I'm going to assume you're doing all right and keep going. And that's not a good thing if you're not. All right. So next one is g of f of x. So this time we're taking g and we're plugging in f. G is 4. Wherever we see an x, we're going to leave a space. And in that space, we're going to put f of x. F of x is 2x squared minus 3. So we get 8x squared minus 12. notice that f of g of x is not always going to equal g of f of x. Any questions on that? All right, what do you get for f of f? So we're taking f and we're plugging f inside. What's the next step? Right. And what do we write inside? And now we write what f actually is. Normally I'd ask you to expand this, but right now, no. Unless you really want to see it. Okay. Any questions on composition? Sure. So I'm going to do it up here. We have 2x squared minus 3 squared. So that means we write it twice. We can't just distribute it like we did over here because of this minus sign. So we have to write it twice. And now we distribute when we multiply or FOIL. So what is 2x squared times 2x squared? And then we have 2x squared times negative 3. Negative 3 times 2x squared. And negative 3 times negative 3. Good, Stephanie? Yep. Well, since we're here, might as well finish it. What do we do next? Yep. So we get 8x to the 4th minus 24x squared plus 18 minus 3. The only thing we can combine are the 18 and the negative 3 to get positive 15. Did I? Oh, thanks. All right. Next thing is odd and even functions. So a function is even if and only if it is symmetrical to the y-axis. Do you know what it means to be symmetrical? Yeah, like you can split it in half. So a function is even if we can split it in half with respect to the y-axis. Algebraically, a function is even if f of negative x is equal to f of x. So if we plug in negative x for x inside a function and we get the original function back, that means the original function is even. We'll do an example of that. On the other hand, a function is odd if and only if it is symmetrical to the origin. And algebraically, we find that if we plug in negative x, we get the opposite of the original function back. Alright, we're given the function f of x equal to x squared minus 5. We want to see if it's odd or even. And we want to do this algebraically. So first thing we have to do is plug in negative x for x. If we do that, we get negative x squared minus 5. What is negative x squared? Negative x squared is just positive x squared. So is this the same as this? Yes, it is. So that means this function is even. Make sense? All we're doing is plugging in negative x wherever we see an x. And if we end up with the original problem back, then it's even. All right, we're given f of x equal to 5x cubed minus x. What is f of negative x? Yes, it will become plus x. What about, what is negative x cubed? It stays negative because the odd function, odd exponent makes it negative. And over here we have negative 1 times negative x, that becomes positive x. So it's odd if f of negative x is equal to the negative of f of x. If we factor out a negative from here, what do we get? And isn't that the same original problem, just with the negative on the outside? Yes, yes it is. So this is odd. Over here we had negative x cubed. What's negative x times negative x? And then we multiply that again by negative x. Yeah, it becomes negative x cubed. So instead of writing a negative in front of the x, I just moved it to the front because it's being multiplied. Any questions on this? Let's try one more example. What is f of negative x? Yeah. Is that equal to this? No. All right. So if we factor out a negative, what happens? Is that the same thing as this? So this one is neither even or odd. When we talk about transformations, we're looking at a parent function f of x, and we're changing it in different directions. So we can be changing it by moving it left to right, up or down, stretching or compressing, and reflecting. Those are all the different types of transformations we have. And each of these variables have a different effect on the parent function. Do you remember what A does? Yeah, so A controls stretching and compression. Do you remember how to figure out which one it's doing? If it's a fraction less than 1, so this is saying that A is less than 1 but greater than 0. And if A is greater than 1, it stretches. So all this means is if A is a fraction that's smaller than 1, but it has to be positive.
I didn't understand that.
I didn't say anything here. All right, what if we have a negative in front of A? Reflection across what? Which axis does it flip across? Yeah, the other one. So a negative in front of the function tells us that it's been flipped across the x-axis. What about h? Do you remember what h does? Yep. So left or right? If we see f of x minus h, which way did we shift it? Remember, inside with the x is always opposite. So because our transformation function starts with x minus h, if we have x minus h over here, that means h is positive. Positive means we're going to the right. If we have x plus h, that means we had a double negative that cancels out and becomes plus. So that means h had to be negative, so we go to the left. And what does k do? If we have f of x plus k, which direction did we go? And f of x minus k? I feel like I only have one student in this class. I see. All right, examples. So how did the function f of x equal to x minus 2 squared plus 3 shift from the parent function f of x squared? So just tell me what the transformations were. How did it change? Yep. So went to the right twice. What else changed? Because we have h is positive 2, so that means we went to the right. So comparing it to this one. So anytime you have a minus and a number here, that means we went to the right. If it's a plus, that means we went to the left. All right, what else changed? Yep. Anything else? No, nothing else changed. All right, we have f of x equal to -2 times the absolute value of x plus 4 minus 3. What are the transformations? This negative tells us that it's reflected. This 2 is greater than 1, so that tells us that it's stretched. So when we're looking at this, we look at them separately. The negative does one thing, and then the 2 does another thing. What else? Yep. Good. Any questions on transformations? All right, last one. We have 4 times the square root of x plus 71 plus -11. What transformations happened? Yes. So this 4 is greater than 1, so that's a stretch. Yes, down 11. Yeah, left 71. So even though there's a plus here, this -11 is the same thing as saying -11.